Oh, God. Hello, can you hear me, Andy?
Yes, we can hear you, but the voice is very low.
Oh, the voice.
We can hear you, but the voice is.
So let's not delay the session any further and let's start it. Square Up, can you help me record the session for now? Thank you very much. Okay, anytime when you don't hear me, please let me know, or when I'm sounding too loud, then please let me know. So let me share the screen. Awesome. So hello everyone, and thank you so much for participating in the lesson. So today we will talk a little bit about, and then we will have the hands-on session on Colab Notebook. And so first, let me introduce you to the panel. My name is Jen, and I'm a data engineer at Home Credit. And with me is Sasikuma, who will be my technical help, and also Masud Rana, who also the technical help for the sessions. So while if I speak too fast, you guys have any questions, please refer to these two guys, and they will help you out. And also one of the person that gonna contribute to my session is Aridam. He's a little bit delayed right now, so he won't be able to join the first session, but he will, if he can return on time, then he will share with us the Spark streaming, which is a very fantastic topic. So a little bit on the content today. We will first go into Spark, and then we will talk about Spark Core API and Spark SQL. And after that, we will have the hands-on session. And after the hands-on session, my friend will join us on the introduce about Spark streaming. And after that, we will have the experience sharing Q&A session. So before I start, I just want to have a quick survey. So how many of us here are Star Wars fan? Anyone Star Wars fan at all today?
Please, can you repeat again? I'm really sorry for my.
Oh, sure. So anyone here is... Awesome. Awesome. So anyone else? I saw one message from Akash. Anyone else here is a Star Wars fan? Oh, okay. Awesome. Hello, Muhammad. Hello, Praveen. Oh, so good to see all the Star Wars fans here. So the reason why I asked that. Oh, also, Eddie. Oh, we have so many Star Wars fans. I'm happy. Because the reason I asked that, because today on the hands-on lab, we will actually use the Star Wars characters data set to practice some Spark SQL with it. Hello, Duke. Duke is my co-worker. So he just joined now to contribute with us to the session.
Hello.
So, yeah, so before we continue on, please download the Star Wars character set and also make a copy of the Colab notebook. Yes.
By the way, Jen.
Yes.
Sorry to disturb you. By the way, Jen, I want to ask you, was your issue got resolved with OpenVino on Google Colab?
Sorry?
I'm Mohammed Ali.
Yes.
So we're having an issue with the Colab, so I was asking you.
Oh, okay, sure. You can actually just open the notebook code and copy the code and run it on Jupyter local. I think it should work fine. Yes. Let me quickly. Okay, so let me. While you guys are downloading the character dataset, let me quickly push this on GitHub so that everyone will have the link to the notebook. Sorry, I didn't think of the issue with the collab. Give me a moment to do that. Yes, give me a moment. Let me upload the collab book here.
That will help me to discuss some advanced aspect in the next class.
Okay, so I think if you go on to my repo, the file should be ready. Okay. Yes, so in case if you have issue with connecting to the Colab notebook, please use the notebook named PySpark Fundamental on this repo to download the code. I will also paste the link to the Keko dataset for Star Wars character. So are we on set on the dataset yet? Okay, so while I'm waiting for a few minutes, I'll talk a little bit about what we will do in the dataset. So as a Star Wars fans, we will explore on things which is like eye color, which eye color is the most popular amongst species, and how many different hair color are there, etc. So yeah, so we will do a lot of data analysis on that. Are we all set on the data yet?
Just one suggestion to everyone. If you guys want to directly import all of this GitHub repo into your Google Drive, you can use Git clone directly in your Colab.
So okay.
Okay. Don't have to copy and paste the code. They can directly just clone whole of the repo directly into their Google Drive.
Oh, okay. I didn't know that. Okay. Next time feature. Thank you so much for suggestion. So for now, let's keep it separate. Next time, I definitely will put it in Google Drive. Sorry about that.
No issue at all. Even I'm testing what you have to type in your Colab in the chat box.
Okay. Okay, sure. So let's move on to the handout left. So, well, some of the feature on the handout left today. Oh, okay, awesome. Thank you so much, Mohammed. So on the handout left, we will go through some of the Spark SQL functions, and we will go to practice some of other features, for example, lazy evaluation, Spark session, RDD persistence, and other exploration, which I will first explain to you the concept, and we will move on to the hand-on. So are we on good yet?
Yes.
Okay, awesome.
Yes, everyone.
Awesome. So let's talk a little bit about Spark context in big data environments. So you might have heard a lot about big data environments and its tech, and like how to analyzing the features. Sorry. Okay, and all the exciting features. So let me first introduce you. Oops, sorry, I forgot to change the screen. So let me first introduce you on the big data environments. So of course, on the underlayer, we have the distributed file system where we will store our data, and it could be on Hadoop. And on top of that, we have the resource management. And on the upper layer, we have the Spark core and all of the APIs, which we will touch today. But I want to introduce you to this graph so that you know like where we are sitting and what is under it and what is above it. Yes. So to the next slide. Spark applications and why I want to bring the class to the attention of Spark, because Spark have a very wide, is very popular and is gaining reputation. You can have like Spark on machine learning, event detection, fog computing, and interactive analysis. And for our class, I think we might be interested in fog computing, because the term fog in computer science is an architecture that extends service offered by cloud to edge devices. So in other words, fog is seen as an extension of cloud, and it offers local data analysis and filtering. So in other words, it acts as an intermediate layer between the things and cloud. So, because during the class, we have a lot of model and data analysts, but we haven't touched much on the infrastructure. So that's why I want to bring up to you to this concept. And also, if you want to further knowing about how the role of Spark on IoT, I would recommend you to watch this video. This is a Spark Summit on 2016. And it talks about Spark Streaming and IoT. And hopefully we will have a session on Spark Streaming by one of our fellows soon. So for the use case, Spark Streaming absolutely is one of the popular use case. And you can see that Netflix, Uber, and Pinterest all use Spark Streaming in their application. And for analyzing the data, yes, I believe we already have that. Let me share it again. Yes, awesome. Sorry about that. So yes, you can read more on the use case later on, but what I want you to remember from here is the keyword of Spark Streaming and Spark API, because if you are gonna go into edge and big data, you will see a lot of it. So let's dive deep in the Spark ecosystem. So remember this picture. Sorry, I'll have to go back a little bit. We are talking about the layer of computing engine and the service API. Let me get the pointer up. So you see, so we are talking about this layer, computing engine and service API, and these only, because if you are building application on top, I would think that you already have the distributing file system and resource management set. So you are building application. So that's why we focus on these two layers. So for the Spark streaming ecosystem. Sorry, just a moment. Okay, so we have the Spark Core API, which we will talk about. And what I want you to be noticed that so I want you to notice that Spark is polyglot. That means it can support multiple popular computer languages, R, SQL, Python, Scala, and Java. And on top of the API, we have others 5 components. Spark SQL, Spark Streaming is for streaming service, MLIF is for machine learning, GraphX is for graph computing, and Spark R, which is just R and Spark. So this slide is basically just a summary of what I said. What I want you to take out from this slide is that Spark has a large community support, and it is very, very important when you learn a new technologies, a language is the community on it. And number 2 is polyglot. So it supports multiple languages, as I mentioned, such as Python, Java, Scala, R, and it's worked with Hadoop support storage system. So you see Hadoop distributed storage system. So it's very good to integrate with big data. Okay. So we let's move on in how Spark work. What you are looking at is a cluster or a group of machines. It's pour the resource of many machines together and allowing us to use all of the cumulative resource as if they were one. So a cluster of machines that Spark will leverage to execute tasks. And these tasks and these resources will be managed by the cluster of a cluster manager like Yarn, Meso, Kubernetes, you know, and let's refer back to the Spark context in environment. We have here is the resource management in Yarn Meso. This could be the resource management for the cluster of Spark. And here we have the model of how Spark work. And from this slide, I want you to remember 2 things. That is the underlying structure of Spark that composed of driver and executor. So when you sit at your client on the far left or far right, depends on your side, you know, so you see the table with a desk. So on the far left from my side, you have the client machine who execute the command and send it to the driver. And on the middle, we see what is called Spark application, which consists of the driver process and a set of executor process. The driver, you see the driver in the box, right? It runs your main function and it sits on a node in the cluster and it responds 3 things. Maintaining information about Spark application, response to the user program input. So when I send, analyzing, distributing, scheduling, monitor, it doesn't go directly to the executor. It goes to the driver, and the driver will distribute the command to all of the executor. And what the executor are responsible to is executing the work that the driver assigned to them. That means each executor is responsible for only 2 things: executing the code that is assigned to them and report the stage of computing back to the driver. So this is the summary of what I just said. And what I want you to remember from this slide is that Spark is a cluster of computing that has driver and executor. It is good for the beginning level. So we are moving to a very important Spark concept, which is the Spark API. So let's talk a little bit about the history of a Spark API. It started in 2011 with RDD, and in 2013 we have the dataframe, and in 2015 we have the dataset. But the dataset is only work with Java or Scala, so I actually haven't experience with it yet. So most of the time when I do PySpark, it would be only for dataframe. So let's have a little bit of comparison between these three, because it's very crucial that you pay attention to this slide and the next slide, because it's the most important fundamental of Spark. You know, all other slides you can forget, but this slide and the next slide, you must remember to be able to work with Spark. So what I want to highlight here is that RDD is the building block of Spark. No matter when you talk about data frame or data set, they're all built upon RDD. And RDD is automatically recovered from node failures. And it supports two types of operation, transformation, and actions. So once you have the RDD in 2013, we have the data frame, which is RDD, but with schema. And later on, we have dataset, which is just an extension of data frame API. So I want to highlight here that RDD can support both structured and unstructured transformation. When you read books on the market, they would say like, there's some confusion, is that RDD use the low-level API, and it caused a lot of confusion that RDD doesn't support structure transformation, but it's not correct. They support both, but then most of people now would move to data frame, and data frame is recommended method for most cases when dealing with relational database. So unless you have like no structure, non-schema, the preferred way is to use data frame, because it will make it designed to make large data set process easier. And also I want to highlight that you can see there in the supported language, you know, RDD and data frame, they both all support 4 languages: Java, Scala, Python, and R. And dataset, we have only Java and Scala. So if you only know Python or R like I am, and you are out of luck with dataset. So let's talk about Spark Core. For actions and transformations. So RDD, data frame, and dataset all have actions and transformations operations. So transformation, transformation, we create a new data set from an existing one. And all transformations in Spark are lazy evaluation in nature. Remember, lazy evaluation is a keyword that you need to remember from transformation. And in contrast, actions, operation, return new transformation, we can filter data. Yes, we can filter data from transformation, but then I'll explain further on the lazy evaluation on the next slide. So action, it will return a value to driver program after running computation. So all actions are executed immediately. So example, if you use action operations such as count, show, write, it will execute immediately. But if you use select, group, order, join, it will wait until you run the action. Muhammad, yes. Yes, I forgot to highlight one thing. Let's back to this frame. So all the API are immutable. So that means you cannot change the data set. You can only create new data set from the original data set. So that's why you use transformation to create a new RDD. Is that what you were asking, Muhammad?
Yes, I wanted to know that, as you said, that transformation creates new data set. So that's why I was asking that whenever we call any function from transformation, it means that it will create a new object, right? Like
Yes.
an array.
Yes, but then it doesn't execute right away. So it will wait until you actually type, for example, show me that data frame, and then it starts to execute. And I'll explain why later on, and I'll also show you the example in the hand-on.
Okay, so it means that lazy evaluation doesn't have any output. For the output, you have to do some action, right?
Yes, that's correct. Okay, so we're done with the most important part of the class. So anything later on before that is just an additional supplement. And of course, Spark streaming would be very interesting. So one example of lazy evaluation that I want to put here so that you can remember the picture later on when we talk about lazy evaluation. So, for example, I go with my family to a restaurant, right? So my brother ordered a cheeseburger, a soup, and I order a soup and a noodle. You know, so the waiter, what they do, they doesn't run to the kitchen right away when my brother asks him to make a cheeseburger or a soup. So what the waiter do is they wait, they collect my order. So, you know, one cheeseburger, two soup, 2 plates of noodle. They take the order, they note it down, and then they send the order to the chef, and the chef is able to optimize his workforce. So instead of like making 2 batch of 2 soup, he just make it 1 batch and divide it into 2 bowls. So that's how the optimization of the lazy evaluation. So, you know, by clubbing multiple orders together instead of executing each time. So the so the waiter optimize it by taking all order at once instead of like waiting for my brother to order. Like each time he order, he run to the kitchen, the waiter run to the kitchen, the chef make 1 batch. Everything is clubbing together. So that is the power of lazy evaluation. And I hope this picture will stick in your mind every time when we talk about lazy evaluation. And there's a very nice video. I actually get this example from Cloud Lab. So I put a link here. So later on, if you like, you can have a look at it.
Jane, can I ask you a question?
Yes.
Jane, so it means that transformations work like synchronous requests. I mean, you cannot do anything until the whole order gets complete, and afterwards, the whole and after once the whole order gets completed, then the work will be done, right?
Not quite, because it's only take action when you want to perform a certain things. For example, if you want to show the result, you know, like when you put on show and then it will return the order. Or when you put like join and map, then it starts to return the order. So for example, if I create a data frame, right? Data frame, let me just quickly do some pseudocode. Select all from data frame 1. Oh, sorry, that's a bad example. I'll just write a pseudocode.
screen. Really sorry to say that.
So when I press enter to this, oh, sorry, I think I private.
Yes, the screen is not sharing, right?
Yes.
It's completely fine. It's completely fine. You go with the flow, and afterwards, when you will move towards the demo thing, and you can show this.
Oh, okay, sure. Yes, we definitely will have the example on the collapse. So I'll show you on that.
Okay, thank you.
So so this slide, just quickly, you know, you don't remember, it's fine, but then you will be annoyed by that. You will be really annoyed when you find that you created a data frame, and then later on when you call it again and it doesn't show up. Why? It will be annoying if you don't remember this, but it's optional. So we will talk about RDD persistence. Hang on, let me change the slide on my screen also. So Spark RDD, as we explained before, are lazy evaluate, right? So thus, if we may wish to use the RDD multiple times, it will result in recomputing of the RDD multiple times. So to avoid computing an RDD multiple times, we can ask Spark to persist the data. That means to write it in either cache or persist, which is like very storage level that you can do it. So I want you to remember that cache is right in RAM and it's temporary. Persist, it use various storage level, and you can see it below, and it's permanently. In the hand-on lab, we will use a cache, and I'll show you why you should learn how to use it. And the RDD also come with a method called unpersist, which lets you manually remove them from cache. Yes, you are right, Banerjee. Yes, it's absolutely correct. So I believe Scikit and Hive, they use this method of. Okay, so so we will move now to the Spark SQL, which is the last session, and also please welcome Banerjee. He will be the one who present Spark streaming. I'm so glad that you made it on time. So Spark SQL. There's three ways actually to retrieve and analyzing data on the Spark. So we can use the RDD way, the data frame way, or the SQL. And the Spark, why I want to talk about Spark SQL is that Spark SQL is the most popular Spark module, and it's used for structured data processing. And Spark SQL is highly recommended to use for data frame and dataset API. So if you wonder about the other two ways to process the data, I have the link here, and you can see that with Spark SQL, the code is significantly shorter, and it's very similar to the SQL, which is very popular, and almost everyone in the data field know how to use it. But then if you want to see other way how people used to use RDD and data frame, I recommend you to check out this link. Okay. Okay. Oh, okay, yeah, I thought I shared. Let me quickly share it again.
Jane, so the Spark is Apache Spark?
Yes.
Okay.
Yes, it's Apache Spark.
Okay. The SQL queries are similar to the MySQL queries, like the general SQL, like Slack and where like these queries.
Well, you can see some similarity, but the syntax is not 100% similar. So we will see that in the hand-on, but definitely, yes, you will have a group by filtering select, and we actually gonna try on that. So let me go back to the slide of what we are gonna use on hand-on section. Yes, so we have select, group by, where distinct. I remove alias, unfortunately, but filter aggregation like use find max function, and there's two ways to do that. Oh, just quickly check, is everyone have the collab link?
I will suggest that please share it again. I mean, so
Okay,
that the
sure.
listeners can also look at it.
Okay, sure. Okay, sure. Let me share it again. Please don't change, edit anything here. Just please make a copy of it. Yes. So is everyone accessing and make a copy of it, all right?
Yes, Spark fundamentals, right?
Yes. Yes. And one thing that please do is finish downloading the characters CSV. So this is for the Star Wars character set that I got from Gecko. And if you download it from my GitHub, it will be in text file, and we need to change the code for it a little bit. So, yes.
Sorry to disturb you. I just want to give you a suggestion that please show people who are new to Kodak that you have to click on file button and then save a copy and drive so that they can also do that.
Oh, okay. Yes.
I think what my experience is that many people usually don't have an experience of Kodak.
Oh, okay. Yes. That's a good idea. Yeah, I haven't think about that. Sorry. Yes. So Colab is a product of Google, and I just got introduced it. Oh, I'm sorry. Can you hear me, ID? Hello?
Yes.
Oh, okay. The other speaker. Okay, he just recommend me to do a short introduction on Colab. So Colab is actually the product of Google. It runs on cloud, and I actually just learned it from this class. So I'm very, very thankful that I got to know it, So we will, I have some explanation plot here already. I think, so I have some explanation blog on here already. So in your free time, please take a look at it. I think I'll move a little bit fast because I want to save some time for Spark streaming and Q&A. So let's start with it. Please run the first and the second blog. I already run it today, so I don't want to run it again to avoid, to avoid like multiple files at once. So once you run the first and the second blog, please let me know on the chat.
Jane, one more favor. I will request you to give one more favor. Please share your GitHub link again.
Oh, okay. Yes, sure.
I'm really sorry for that.
Yes, let me share the GitHub link again.
So that I can clone it.
Sorry. He just mentioned that I should share the GitHub link again because this had my CSV file. Okay, so please go ahead and run the first and the second plot. It's basically just install Spark and Hadoop, and also Java environment and PySpark in your local local cloud computing platform.
Yes, Jane. Both of these cells has been placed.
Yes, it's all. So all of the code that required for this hand-on is in there. Spark fundamental IPython notebook is there, and the character.csv is where we get the data set. Okay, so after we imported the libraries, we first create the Spark session. And I want you to note this line. It have the star here. It means that all as many threads as there is in your machine. And there's other different parameter that you can use with it. And for more information, please click on the link and you will find different parameters for it. For now, I'll just use all. And then you click on list and you will see the file of, oh, sorry, that's bad. Sorry, skip that part. You guys probably don't have the file yet. Okay. So after you build the Spark session, I want you to take note of this. So when you look online, sometimes you see like different way of building Spark session. And this is also another way. And this is the old way, and the two way is valid. You can use this one, or you can use the other one that I show you. So it's up to you. There's some explanation on this, and you can read it later on. So this part, we will import file, and this is where you should import your CSV file of Star Wars character in here. So, you know, once you run this code, you choose file you import, and you will have the okay, I think I hear noise. Okay, so you import and then you press enter, and then you guys should have the characters.csv on your file after you complete this step. So everyone see characters.csv in your file, in the you guys file yet?
Jane, just 1 second, right? Please wait just for 1 second.
Okay. Okay, please let me know if you guys are able to get the characters.csv on the Colab.
Yes, Jane. Yes.
Okay, awesome. So now we just read CSV. So you know we want header, we want infer schema, which enable us to infer automatically different data type for each column. Right. So let me run the code. And then we print schema to see what we have here. And show the first 5 items. You know, these are very basic, and you have it similar to Panda, so I'm not going into explain it, and similar to this one to see the total rows. And this, you know, get a sample. So if you have a large data set, you might want to do that. It just get some sample instead of getting all of the data, because it can really wreck your RAM if you like. Okay, this is a very don't do this. I
James,
yes.
I'm sorry to disturb you. The fraction is 0.1, but the description is 20% of the
Oh,
data.
yes, yes, I actually fixed it. So originally I was putting 0.2, but then somehow I put it 0.1. So let me just run it to see. You see, this is one example of lazy evaluation. When I press, it doesn't show anything. But when I do this, then when I click show, then it's actually compute. It doesn't compute when I click data symbol. When I click this step, it doesn't compute. But lazy evaluation is, it will compute in this step when I type simple.show. Okay, we will go more later on that. So, oh yes, here that I said. So you know when this is data frame simple.show. This is the line where it starts compute, and that's why it's called lazy evaluation. That means it doesn't do anything until it's forced to do it.
And James, the show function, the show method is action, right?
Yes. So now let's create a 10 view for that. And we can start with exploring our data set. Okay. So let's see the description of height. So describe function is give the statistics of the column. So the column I pick height, and you can see that, you know, we have 87, the line, where's the mean, where the stat, where the dividend. And this is why you should clean your data. Yeah, this is the data cleaning error. I should have removed the NA from there. So this is where the Spark SQL, you see, we create a Spark section up there. So let me go on here. Here, Spark equals Spark section. So down there, when I want to call the SQL, sorry, let me get down. So I call it Spark SQL. Spark I already defined in the up on the top, and it's basically very similar to MySQL and the SQL that you have worked with. So it's where we find people who have height less than 150. And let's try a group by function to see the relation of species and eyes color. Can you guys see? So you can analyze the SQL function. So select species count. It's very, very similar to normal SQL. And here, when I talk about RDD persists, this is what I meant. Now, if I want to start a new data frame, the data frame species eye color will be lost unless I catch it. So let's run that. And let's compare with this data frame now. I don't catch it, right? So this data frame is basically just select the distinct hair color. And when I press this, it's lazy. So it's not yet execute, remember. Select is lazy, it's not execute. But when I press count here, it starts to give me the result. Yes.
James, so it means
Yes.
that there are 12 types of hair colors, right?
Pardon?
of characters. There are 12 types of shape color of characters, right?
Sorry, can you type in the? I'm not sure I got the question.
Yes, yes. Now you can hear me clearly. Uh, I mean, there are 12 types of hair colors, right? We count like brown, black, like these are the hair colors. So there are 12 hair colors, right?
Mm, sorry, I cannot hear clear. Can you type the question instead?
Yes, yes. I just read the description and it got clear. Thank you.
Oh, okay, sure. So, okay. So what alias is used for rename. So you know in SQL you have like select this column as this column. So select A as A1, B as B1. So in here we can use the alias function. And my example is not that good, but then when you go into join and rename column, it will be more useful. But it's too late now. But then I want to highlight this. Remember the data frame hair color. So so now if I want to call it again, it won't work because we're not serving it into cache. So you know it won't find. I guess it still save it here, so it's not a good example. It haven't dropped it yet. Yes, okay. So normally when I compute all the data frame and then I go back to the previous data frame, it shouldn't have it because it's not saved at cache, so it would already drop it. So we go into the filter. Let's see which species have the more than 10 count of eye color. Human, we have brown color. Awesome. Okay, we're moving to the last one before we can catch up on some streaming explanation. So for aggregate, so instead of doing group by aggregate, we can do this way. So we using the data frame species eye color, we want to find out the maximum number of sets of eye color. So which is returned to, it should return to this value. You know, human number 17 is the highest number. And another way to write it this way, which return the max of the species eye color number, the column number. Yes. So that reached to my end of hand-on. I'm sorry, I have to go fast because we have only a short time. So should we move on to the Spark streaming? Let me chat with. Hey Aridam, do we still have time for Spark streaming?
Yes, Jen.
Awesome. Awesome. So I'll give the session to you and please share with us the Spark streaming.
Sure. Am I audible to everyone?
Yes.
Okay, can you stop sharing, Jane? Then I can share. Jane? Jane, you there? Jane, could you please stop sharing because Zoom is not allowing me to share till the time you are sharing your screen. Thank you. Okay, so it's visible to everyone, right? The screen is visible, right? Great. So we'll have a very short discussion on Spark streaming. We have some limited time. Fine. So Spark streaming is again one Spark API that is provided by Spark to handle streaming data. Okay. Now, what is streaming data? In streaming data, we get data as a continuous flow. Okay. For example, if you're analyzing the trending topics on Twitter, right? So you need to receive the data from Twitter in a streaming manner, or maybe the Amazon is capturing the user's viewing habit, like what kind of product the user is viewing currently, and what could be the best recommendation for the user. So again, the data is coming as a continuous stream. So it's not like a fixed file, or it's not like a any database or DBMS or something. It's just like a stream of data. Okay, continuous flow of data. So when you need to work with that massive amount of streaming data, then you can go with the Spark Streaming API. Okay, fine. So this is the introduction slide. So this is Spark Streaming is an extension of core Spark API. And it's scalable, high throughput, and fault tolerant stream processing. Fault tolerant means if some node goes off, or if something happens where the computation is stopped, then you can still resume the process. Okay, so data can be ingested from many sources. It's not like you can use only some fixed sources, or maybe fixed sockets, or maybe database. Data can be ingested from many sources, and you can use multiple sources. In the image, you can see that different popular sources, data sources for streaming data are shown, like Kafka, Flume. It can be HDFS, the Hadoop file system. It can be Kinesis, it can be Twitter. It can also be from some text file. It can be some kind of remote directory in the HDFS, where a particular text file is gathering data in a stream format. So when do you get stream data in text format? When you generate log files, right? In a particular log file, the log information keeps on adding, right? Excuse me. So the log information keeps on adding in the text file. So different sources can be used as the data source for Spark Streaming API. And after the processing is done, after the analysis is done, you can dump the data and dump the result again to multiple things like HDFS. It can be a relational database. It can be NoSQL database. Right? It can be dashboard, like if you want to see some continuous flow of data, like how the connection requests are coming in your remote server, right? So continuous flow of connection requests, or any kind of API requests. So you can see in dashboard, right? You can integrate different dashboard with Spark Streaming and can show the data. Data can be processed using complex algorithm expressed with high-level functions like map, reduce, filter, right? Those kind of high-level functions you can still apply on the streaming dataset using Spark Streaming. Processed data can be pushed to different file system, and one important thing and very interesting thing is Spark's machine learning library can be used and graph processing algorithms can be applied on Spark streaming data. Okay, of course, applying algorithms, machine learning algorithms on streaming data is a little bit different because remember that whenever you apply any machine learning algorithm on a fixed data set, it's kind of, you have a training data set in a file, you have a test data set, you train the model on training data set and you test it on the test data set. So you have a fixed amount of data for the training purpose, right? But what will happen if you have streaming data where continuously data is coming up, right? Data is coming like a flow, right? What to do so in that case? So we'll see that, but in Spark streaming allows you to implement machine learning algorithms which are provided by Spark ML library. So you can apply those algorithms on Spark streaming data also. Okay. So now let's see that how Spark streaming works, like how it captures the data and processes it. So Spark streaming receives the live input data stream and divides the data into batches. Okay, this is very critical thing to understand, that the data is coming like a stream of data, like a continuous flow, but Spark is chopping it down, right? Spark is dividing it into different batches. So you can see in the image that the batch is shown like batches of input data. Yeah, so these are the batches. This is a set of data that is a batch. This is another batch. This is another batch. So this batch is getting created based upon the interval that you provide. Okay, so whenever you create the Spark streaming session, so you can define the interval you want. Like if you define that 1 second, so in every second the batch will be created. Every second the whatever data is coming up, that will be clubbed into a single batch. Okay, if you mention the session as sorry, the interval as 20 seconds, so that means in every 20 seconds one batch will be created. Whatever data you are capturing in every 20 seconds, that data will be clubbed into a single batch, and that's how the streaming data is getting converted into batches by Spark streaming. And after that, batches are processed by the Spark engine to generate the final stream of results. So again, you can see the results are also in the batched form. So each batch, so this first batch will be processed and this first result will be created. Then second batch will be processed and second set of result will be created. Third one will be processed and like this, okay, and so on. So your continuous stream is getting divided into batches. Then Spark engine is applying different high-level functions, algorithms to convert or to do the analysis, to do the processing, and then final result is getting generated in this form, these batches. Okay. Now, talking of machine learning models, so there are some machine learning algorithms which are specially written for streaming data. Okay, you can see streaming linear regression is there, streaming k-means algorithm is there. So those algorithms are specially designed for handling streaming data, and using those algorithms, you can train the model online. Okay, what is online? Online means as the data is coming, you are also training the model at the same time. In traditional machine learning methods, or in any kind, like if you are applying your machine learning model for by using any algorithm like random forest or SVM, or if you are using any kind of CNN or RNN, you have a fixed set of training data, right? You are not doing anything online. That say data set is fixed, and you are training your model using that particular data set. But here you are using the streaming version of the algorithms. You can train the model online, okay, and at the same time you can use it for prediction. Now if the streaming version of algorithm is not available, because all the algorithms cannot be developed or yet to be developed as with the streaming version, so if that is not available, you can still train your model. How is it possible? So you can take a set of batches. Okay, you can take a set of batches and fit those batches into your model. Okay, so your model will be trained based upon a set of batches. Okay, this batch of input data. Okay, so in that way also you can apply, but this provision of applying machine learning models is always there in Spark streaming. So D streams. Okay, D streams. What is D streams? Spark streaming provides a high-level abstraction called discretized stream. Okay, the batches that we have just learned, those batches are nothing but discretized stream or D stream. It represents a continuous stream of data. Okay, so in every interval, the batch is getting prepared, and it looks like the data looks like a continuous stream of data. It can be created either from data streams from sources like Kafka, Flume. Kafka, Flume, these things are also Apache products, and Kafka and Flume, these things are used for mostly streaming data, mostly for handling streaming data. Okay, so you can take the streaming data from Kafka, Flume, Kinesis, or by applying high-level operations on other disk streams. Okay, so you can create one disk stream from other disk stream also. Fine. And internally, a disk stream is represented as a sequence of RDD. You can have different RDDs, like a chain of RDDs, and each RDD disk stream contains the data from a certain interval. As I mentioned you that this interval needs to be defined. So whatever interval you define, therefore at every that much second, your batch will be created. Okay. So you can see in the image the RDD at time 1, that is the data from 0 to 1, RDD at time 2, the second, the data from time 1 to 2 will be there. Sorry, others, could you please go on mute if you're not asking anything?
Arindam brother, I have a question.
Yeah.
So as it's a continuous data, so we can consider it as a real-time data. I mean, for example, let's
Yes,
say
it's real-time data. Continuous data means real-time data, right? So there is one question in the chat window, that relationship between the streaming and IoT. So some IoT is nothing but your sensors and actuators, right? Edge devices. Then from the edge devices, you get continuous flow of data. Okay, just imagine a CCTV camera, right? The CCTV camera is sending a continuous flow of, it can be a video, right? Right. So it's a continuous flow of frames, right? So otherwise it can send you the maybe the weather information, maybe the traffic information, right? So that is also that can also come as a continuous stream of data, right? Like a log file is getting generated, right? So from the edge devices also we can get data streams, and when you need to do the analysis, centralized analysis, so you can collect those data as it comes, right? As it comes, and do the analysis. Okay, you can create the batches, and you can apply your models. You can do the prediction. You can use different high-level functions on that data stream, right? So that is the basic understanding of Spark streaming. And from the edge devices, definitely we get streaming data.
I remember just a question from what you told me. First of all, thank you for clarification. And the second thing is, let's say we have an AI model and the data is coming on a real-time basis. So how do you think that Spark can help in updating that AI model with the real-time data coming?
You already have a model that is trained, or you just want to implement the model for the first time?
Yes, and on a real-time basis, it continuously apply inferences on it.
So real-time data is coming, but here you can see that the real-time data, the streaming data, is getting converted into batches, right? So you can take like this is not a stream of data anymore. This is like a stream of batches, or like a chain of batches, right? So batch is nothing but at every interval the batch is getting created. Okay, a set of data. So you can take a set of data in the form of batch and can create your model, like train your model on that. It will be even clear. It will be even clearer when we'll discuss structured streaming. I have one slide for that. Just hold on for a minute. Okay. But anyway, so these streams, the operation, when any operation is applied, it can be any high-level operation like flat map or map, reduce, filter, anything. So if you want to apply any function, just it is applied on every batch, and a new batch, or you can say the new disk stream, is created, right? So this is the first disk stream, the first batch, the data from 0 to 1, and if you apply flat map operation on it, this new disk stream will be created. Again, from the second disk stream, again another second disk stream will be created. So this is the original disk stream, or a stream of batches, and from there, after applying any kind of function, the function will be applied on every batch, and a new set of batches, a new disk stream will be created.
I remember one question.
Yeah.
Sorry for disturbing you again, but I really want to understand this whole topic. I mean, this is very important. So that's why I'm asking you that can we define interval by ourselves? And the second thing is,
Yes, you can define it. You will have to define it, the developer.
okay, so we have to define the interval first, and the second
Right.
thing, it can this whole process can be automated. I mean, like first we define the interval, and after running the model, it automatically updates itself from afterwards that interval. I mean, the data continuously starts coming in, and after each model, automatically it starts to apply inferences on it, or not in batches. In batches.
Okay, now for the model, see, I told you that for the model, you can train models in two ways, okay, either online or offline. Okay, for online mode, there are some streaming algorithms available, but not all the algorithms are converted into their streaming format or streaming counterpart. Okay, so some streaming algorithms are available, like streaming linear regression, streaming k-means. So there you can train the models online. But if you want to train the models offline, then you take a set of batches that will be even clearer in the structured streaming format. So take a set of batches and train your model on it, then deploy that particular model on the maybe the next stream of data or maybe some other data.
Okay.
Okay, maybe you are your training model for all the streams which came in the system since last 3 days. Okay, you train your model on that, and now next time onwards, whenever the new stream will come, your model will start predicting.
Okay.
Because you have deployed that in the system.
Okay, so that
Got it?
means that every batch will help in understanding, in making model better, and will apply better weights on the next upcoming model, like batch propagation.
Yeah, for online streaming, you can, for online streaming, like till the time you are training the model, the online training can be done. But when the model is already implemented, then you cannot change it, right? Because that model is already trained and you have implemented for prediction, right? So at the same time, when the data is coming in the streaming format, it will predict each batch, okay, as it keep on coming, as the data will keep on coming, right? But you cannot change the model itself on the go, or you cannot change the model once it is trained and deployed. That is possible in the federated learning. I had a session today morning on federated learning. So if you want to learn about federated learning, I will share the webinar record and PPT. So there you can change the model itself, okay, based upon your local data. Got it. But here you cannot change the data. You can train your model from streaming data, but once it is deployed, it's not changed. If you change it, then that is considered as retraining.
Right, and that's why we have to, if we have to go for that option, we should choose federated learning instead of.
Yes, federated learning. Yeah, based upon the use case, you will have to think of the technology. Okay.
Thank you.
Yeah. Fine. So built-in streaming sources, we'll discuss about some streaming sources, like some basic sources are there which come with the streaming context API. For example, file system, socket connections. So there can be some server socket and or the port. So in that particular port, whatever server is running, or whatever application is running, if that application sends some data, the Spark streaming will catch that data or receive that data in the streaming format. And there can be some advanced sources, like I discussed, that Kafka, Flume, Kinesis. So that kind of external systems can also be integrated with Spark, and you can define your whole ETL pipeline. Okay. Multiple input disk streams can also be created. So if you create multiple disk streams, then there will be multiple receivers. And a number of, this is important, the number of cores allocated, like CPU cores allocated to Spark streaming, must be more than the number of receivers. Okay, otherwise what will happen, the data will be received, but the operations will not be done. So this is structured streaming. This is the only one slide that I've kept for structured streaming. So it will help you to understand that how the machine learning model can be trained So you can see the data stream is coming like a set of batches here. This is the one batch, another batch. So as the batches keep on coming, so the temporary unbounded table is created in the memory. Okay, so from each batch is actually appended to the table. Okay, each batch is appended to the table. So the first batch will be appended first, the second batch will come and the second batch will append it. So the size of the table will be increased. Again, the third batch will come and the size of the table will again increase. So whenever you are getting the tabular structure, you can use that particular table for training your model. And once the model training is done, then you can deploy that model for doing any kind of prediction from the streaming data. Got it. So the structure streaming, this is called structure streaming, a little bit different from the basic streaming operations. So in the structure streaming, a table is created and it looks like a data frame, and any kind of operations you do on the data frame can also be done here on this particular tabular format. And so it gives you a tabular structure, and that is why it's called a structure streaming. Okay. So yes, so that's all about streaming. I did not keep any more slide because we have some limited time. So if you want to learn more about Spark streaming, so you can go to the official document, and some small experiments are already mentioned there. I mostly use Scala for streaming, Spark streaming, but you can use PySpark or Java or R. I don't think if R is possible. I have not used that, but you can use Java or Python if you want. Okay, whatever language you're comfortable with, you can use Spark streaming for that. And also you can deploy your machine learning models there and do the predictions. So any more questions? Okay, Ayad Taha is asking one question. What is the relation between Spark streaming and IoT I discussed? Will IoT push data to Spark stream directly or through, for example, MQTT broker? Yeah, it can comes from a broker. It can comes from any sources. Like it can be Kafka. It can be like simple socket. Like some server is collecting the data and sending to Spark application. It can be anything. Whatever way you want to deploy it, you can make your ETL process accordingly. Sure, so Swarup, I will share this slide, or I can send this to Jen. Jen can merge this and can say whatever is suitable. We'll do that.
Arindam, brother, I have a question that, for example, like you can use Flask APIs to do this work and to push the data, and afterwards using that data we can apply PySpark on it. So is this possible?
So you want to use Flask API?
Right. I mean the easiest
Okay.
option.
Yeah, so Flask API, see in the Flask API, what you do, the Flask API is basically for developing web services, right? So you can write some REST API, you can deploy that. So if your REST API can send data in the streaming format to Spark, then you can use Flask API. Maybe your REST API is, you can make your Kafka, or maybe just your API is publishing data to some text file or in a particular socket. Okay, and Spark streaming API is taking the data from that particular socket or maybe from the particular text file. Okay, so Flask is for hosting the REST API. So REST API can be deployed using Flask, and if your REST API generates some log file or some kind of streaming data, then that can be fed into Spark streaming API. That is possible.
So it means that the CSV file generated via Flask API can be fed into the Spark.
Yes.
And then we can apply PySpark and Spark SQL function queries.
Right. You can use you can use any functions and ML libraries.
And I have another question. What do you suggest that if a person is new to API side and so what he or she does? I mean, I'm asking for specifically for me. I mean, I have many models trained in TensorFlow, carried. But the problem is that none of the model is deployed. I mean, I personally want to deploy those models.
So see, Spark is mostly used for big data. Okay, if you need to handle very large amount of data, massive data set, and uh, also speed is something you need, right? Speed, because Spark is faster than other Hadoop MapReduce system. Hadoop MapReduce is good for batch processing. Okay, but Spark does everything on memory, and since everything is done in memory, so the processing is a little bit faster, fetching the data and storing the data, etc. So if that kind of massive data you're handling, you can go with Spark. If you are not handling massive data, specifically distributed data, not only massive but distributed, when data is distributed across several clusters or servers. Otherwise, you can just develop your model and deploy it like you are deploying it in OpenVino, right? This is again a deployment platform. You can deploy it like a Flask API. You can make a Python script to read your model, the trained model, and do the prediction from the file, the test file, and you can deploy that script as a cron job, or you can deploy it as a like there are several ways. Like it actually depends upon the use case.
Okay. Right. And for example, if a person wants to create a mobile app, and in the mobile app, the person wants to deploy an AI model, and of course the users will use that app and generate some data, the user data. So how do you think this infrastructure can be facilitated by PySpark? I mean, it's like Spark.
So deploying a mobile app.
Yes.
In the mobile app, so what user will generate some data, and you want to train your model on that, right?
Right.
Okay.
So
Spark is basically used for centralized system. Like when you have, of course, Spark needs quite large amount of infrastructure, and it may not be deployed always on edge device, but edge devices are used as a data source for Spark. Okay, so edge device can collect the data, can send it to a centralized server, or there's some data node where the data is getting stored. These data nodes can be distributed across the globe, and you can send data from there. Sorry, you can train your model using Spark. But for the mobile phone applications, if you are gathering user data, you can do two things. Either you can send the data to some edge device like fog node or some other devices, edge servers, right? So there the data will be stored, and some centralized server will run the Spark applications across the data nodes to make the analysis. Okay. Otherwise, you can, for the hyper personalization, again you can go for federated learning, and there the small model is deployed, teeny model is deployed on the mobile phone, and using the local data, the model is further retrained, and only the model updates are sent back to the centralized server. Okay. Yeah. So these two are the two different approaches for solving a specific problem.
Okay, so what I have understood is that if these two conditions are met, then one should go towards Spark. First of all, that there is a distributed network of uh, data generation.
Yeah, data is distributed. Like data is not stored at a single location. It is distributed across different servers. Then you can go for Spark, because the data is really huge. Data is massive. No one can save it on a single server. Okay, and also the data is critical, that you cannot rely on a particular server. You need a fail-safe system where data is getting replicated on 2-3 more servers. So on those cases, you can go for Spark. If you need a small scale application, like you do not have much data to process on regular basis, but you can train your model once and can deploy it, you can go with the other approaches.
Okay, like simple SQL.
SQL is again for data storage purpose, right? It's a storage solution. So SQL will not help you for deploying model.
Yes, yes, and Spark helps in gathering the data as well as managing both,
Yes, 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 yes.
and as well as all about just the storage. For getting the data,
Storing
you
the
have,
data, yeah. Storing the data. Some basic analysis you can do using the query languages, but that's it.
and for getting the data, you have to rely on any APIs, right? For the small
Right,
scale.
right.
And can you give one example, one practical example where Spark applies? I mean, for example, like
Spark applies like any massive data set. When we handle massive data set, like Amazon is giving you the personalized recommendation, right? Facebook is giving you recommendations. Twitter is giving you the trending topics. So those are the applications of Spark because huge data set.
okay, so it means that if we take an example of WhatsApp, so the users are generating data, but
Mm-hmm.
uh, but at the backend of WhatsApp, the server side, the backend engineers are using Spark. Uh,
Right. Might be, yeah, might be. That could be also an operation. Like to understand how users are interacting with WhatsApp, what could be the better feature for a WhatsApp, so they can analyze those things for developers, right? The WhatsApp developers. So that kind of things. Hello, am I audible? Okay, fine. We can drop the session. We can close the session now. And if you have any further question, please feel free to ask me on the Tech Webinar channel, and I will answer your questions there. Fine. Thank you, everyone. Thank you for joining and attending this webinar from the beginning. So bye-bye. Have a good day.